Now that we know the surface area of a sphere, it's relatively easy to find the volume of a sphere. So here is our sphere of radius capital R. Inside the sphere, I draw a spherical shell of radius little r and of thickness dr, so that the volume contained in that spherical shell is dv, is equal to the surface area of the spherical shell, 4 pi r squared, times the thickness of the spherical shell, which is dr. So to find the volume of the sphere, we need to only integrate dv. So we can take the integral of dv. That's the integral of this, so it's 4 pi times the integral of r squared dr. R can go from 0 out to the radius of the entire sphere, so from 0 to r. That's just the integral of a power law, so we can use the power rule. So that's 4 pi r cubed over 3, evaluated between 0 and r. The lower limit is 0, so we get 4/3 pi capital R cubed for the volume of the sphere. Everybody has this formula memorized. So once we know the surface area of a sphere, it becomes relatively easy to find the volume of the sphere. So another thing to note is that the volume of a sphere is the integral of the surface area, and likewise, from the fundamental theorem of calculus, the derivative of the volume of the sphere gives us the surface area. So a very close connection between the surface area of the sphere and the volume of the sphere through the calculus. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.